Hey everybody, this video is about the Khan Academy assignment in behavior of rational functions. All right, so we're going to use Desmos and we're going to look at these functions, and the questions are all about as you go out to negative infinity, x goes to negative infinity, or as x goes to positive infinity, what happens to the function, right? So the question here is, what does f of x approach as x approaches positive infinity? All right. So, and I've also need to pull this up right here. We're gonna have to do a little bit of writing here as well. All right. So the first thing I want to do is I'm going to write this function down. F of x equals 5x cubed minus 3x plus 4 over 10x cubed minus 7. All right. So let me shrink this for a minute. So first thing I want to do is look at it without Desmos, right? So really Desmos is cheating. The idea here is by just looking at the function, we should be able to figure out what happens to the value of the function as x gets very, very large. In this case, large in a positive way, okay? So what happens is, as x gets very, very large, these two leading coefficients kind of take over. And these other terms, like this minus 3x, is almost negligible, right? And I'm talking about for very, very large values of x. You could pretty much ignore all of this, and you could ignore this because x cubed is just going to get crazy big as x gets crazy big, right? Now, since the power of these are the same, then what's going to happen is this graph at some point. So if I were to draw a sketch here, let's say there's 1. The value of these coefficients is 1/2, right? So it's like right here. There's going to be this artificial barrier, and the graph is going to approach that at some point. Now, I don't know how it's going to behave in the beginning. It could do all kinds of crazy stuff, but I do know that it's going to either come down on this this horizontal line, which we call a horizontal asymptote, right? From this direction, or maybe it'll come up like and do this here, but it's going to approach this invisible barrier, which is a horizontal asymptote, and the equation of it is y equals, that's part of the dashed line, that's not a negative, right? So the equation of it is y equals negative 1/2. And I got that by putting 5 over 10. Sorry, not negative 1/2, positive 1/2. So there's 1. This right there would be 1/2. Right? So that should be the answer to this. Now, let's take a look at the graph on Desmos. And I would, just for your own sanity, because you can easily get these wrong. As you can see, there's like, 6 choices here. So I would definitely take your time and graph it on Desmos as well. So let's take a look. So I'm going to put in 5x third x 4 over 10. See how the graph just keeps changing. 10x raised to the third minus 7. Okay, so here's the graph. And as you can see, as you go out to positive infinity, it just starts to get really close to 1/2. Now it looks like maybe it crossed it, but let's take a look at what happens as it gets big. So if I do f of, oh no, let's do f of 10. What does that equal? Really close to 0.5, right? Let's do f of 100. Even closer to 0.5. So it's approaching the, it looks like it crossed it, and then it's approaching it from underneath. I can go ahead and graph that line. So y equals 0.5. Here's the line it's approaching. And I can zoom in on it a little bit, see kind of what's going on here. So if I zoom in this way, you can see somewhere around, see it crossed, right? It was approaching it and then it crossed it. And then as it goes out, what's going to happen is it's going to get so far away, but then eventually it's going to start coming up towards it again, right? So let me zoom in this way. Well, this is the best I can do. So you can tell, I guess these values work a little better than trying to manipulate the screen on the graph, which I'm not very good at. You can see that it is getting closer and closer to 0.5, positive 0.5, which is what I chose here. So I'm pretty confident that my answer here is correct. All right, let's try another one. We'll get this thing back to 0. Okay, get rid of these. Rid of that. There we go. So I need this to go from -10, 10, 1, and the y-axis to do the same. Okay. I'm going to have to pull up another problem set. I guess that was the last one in the set. So let's try that again. All right, I'm going to write it down. H of x is 5x cubed plus 17x over x to the 5th plus 12x. All right. So in this situation, this is a 3rd degree polynomial. This is a 5th degree polynomial, which we call a proper rational function, like a proper fraction. So for instance, 3/5, if you remember your fractions, we called that a proper fraction, right? Proper, because the bottom's bigger. But 5/3, if you remember, it's called improper. All right, so we're doing the same thing here with degree, right? I've got 3/5, which is proper. Whenever you have a proper rational function like this, there will be a horizontal asymptote at x equals 0. So that means when you graph this thing, it's going to, at some point, approach the y-axis, either from above or from below, right? But what's certain is the x-axis, which we call y equals 0, right? That's the equation for the x-axis, is going to be an asymptote, which means as x goes to positive infinity, y is going to tend to go to 0. It's going to approach 0. And as x goes to negative infinity, y is going to approach 0 as well. Okay, so now let's take a look at the actual graph. H of x equals 5x third plus 17x over, I should have put parentheses around that, over x fifth plus 12x. All right, there it is. And as you can see, x is approaching, as x approaches positive infinity, y is approaching 0. Now to be sure, to make sure that, how do you know the graph doesn't do something crazy later on? You can kind of, without trying to scroll over your graph and look way out into the hundreds, you could just do like, well, what is h over 100? It should be very close to 0. And as you can see, it is. It's 0.0005. And every time I make the number bigger, we get closer to 0, right? So that's when you go out to 1,000, when you go out to 10,000. Now you've got, what, 7 zeros in front of that 5? So that means 0.000000005, and so on, right? So that number just, as x, I'm plugging in an x value. As it gets bigger, your y value is getting really close to 0, but it will never reach 0. Okay, so question is, find the horizontal asymptote, and it is y equals 0, right, which is the x-axis. Next question. Okay, I'm going to write this down. So g of x is 4x squared minus 6x to the 4th. So be careful here. When I first started doing these, I was tricked. The top of this fraction has degree 4. You go with the biggest power, right? So that's degree 4 on top over 2x plus 5. So the bottom is degree 1. So this is improper. So this is not going to have a horizontal asymptote at all because it's an improper fraction. Right now, if the degrees are the same, like if this were a 4th power up here and this were a 4th power up here, then there would be a horizontal asymptote, and it would be y equals whatever the ratio of the coefficients are, and I'll talk about that in a minute. All right, so let me take a look at this first, just in terms of the problem. What's going to happen? Oh, I already forgot the stupid question. Hold on. The question was, what does g of x approach as x goes to infinity? Okay, so as x gets very, very big, this term is going to take over, right, on the top, and this term is going to take over on the bottom. The top is going to grow much greater, right? It's going to get bigger faster than the bottom. So it's going to go off into infinity because the top of the fraction is growing faster. And this is why improper rational functions don't have a horizontal asymptote. It's because they just grow and grow and grow. Now, as x gets very big in the positive direction, you've got to be careful here, right? So let's talk about what happens as x approaches positive infinity, right? G of x should approach, let's think about this. This is a negative value. In x to the fourth, since we're in the positive numbers, because we're going to positive infinity, then this will be positive and this will be positive, right? Sorry, this will be negative because it's minus, and this will be positive. And the whole value then is a negative over a positive, which would be negative. So it should go to negative infinity. Now let's talk about what happens as x approaches negative infinity. What's this g of x approach? All right. As we go to negative infinity, getting into the negative numbers, that even power is going to keep this positive, right? But that negative 6 is going to turn it into a negative. So this is going to be negative on top, right? Even though you're plugging in a negative number. Does that make sense? So a negative raised to the fourth power is going to be a positive, and a positive times negative 6 is back to a negative again. Now on the bottom, when you plug in a negative number and you multiply it by 2, you still have a negative number. So you're going to get a negative over a negative, which is a positive. So it's going to go to positive infinity. So as x goes to positive infinity, g of x will approach negative infinity. And as x approaches negative infinity, g of x will approach positive infinity. So the question is, what does g of x approach as x approaches positive infinity? The answer should be negative infinity. So let's see if we can actually show this on Desmos. All right, so I'm going to change this to 4x squared minus 6x raised to the fourth over x plus 5. Okay. So here's the graph. And the graph is, what did I say? I said as x goes to positive infinity, y is going to go to negative infinity, right? And then I said as x goes to negative infinity, I said y should go to positive infinity, but it doesn't look that way, right? It looks like that's not true from this graph. We can scroll up here. See, it looks like it just keeps going down forever, but it's possible that we're not seeing all of the graph here. So you want to basically plug in a number, right? So here you see I've plugged in like, I don't know, what is that? 1,000, million, billion. That's a billion, right? And we definitely have a negative number. So my answer on con is correct. As x is getting big in a positive way, y is getting big in a negative way. So that goes down. I mean, that goes down on this side. But what if I change that to a negative? My prediction was that would be a positive. So let me make that a negative. And as you can see, it is a positive, but it doesn't look that way on the graph. So they can be tricky. And it must be because I'm only seeing, a small part of this graph. I'm not seeing the whole thing. Now I can try to zoom out. I'm not very good at this, but I can try to zoom out on this thing and see what the heck's going on, right? Like there must be something else in it. It must be this way. There it is. Hiding, right? So way up there is the other part of the graph. And I wouldn't have known that had I just looked at that graph and the piece that showed up. So be very, very careful. Use this method here. Just put in a very big positive number and then a very, very big negative number to see what the graph is doing. Don't just trust the picture that shows up on Desmos. All right. I wish I knew how. I'm going to have to learn how to reset this thing quickly. I know there's a way, but I just can't remember. All right. So, check to see my answers right then. So this should be correct. Okay. All right, so let's take a look at this. We've got 8th power here and 8th power here. Okay, so these have the same degree. This has degree of 8. This has degree of 8. Therefore, there will be a horizontal asymptote. And since they're exactly the same degree, the horizontal asymptote will be this coefficient, which is 2, over this coefficient, which is -1, right? There's a negative -1 right there. So -2. So as x approach, what does g of x approach as x approaches negative infinity? It should be -2. It should be. Now, let's put this in and let's see if that's right. So 2x plus 3x third plus 5 over x third minus x. Or you can't hardly see it because my window's so screwy now. But let's see if I can make it right again. Here we go. See it a little better now. All right, so I have to kind of squeeze it that way so you can see it. So this graph then should be approaching the line y equals -2. So if I put in, oh, and there you can see, when I put in -1 billion, I do get -2, right? And if I put in positive, I still get -2. Now it's not really -2, it's just so close to -2 that it rounds it to -2. If I get rid of a few zeros, it's because it's x to the 8. So it's going to approach -2 very, very fast, right? There you go. So at 100, it's already super close to -2, right? At 10, it's really still close to -2. So the graph very quickly approaches -2. Remember, that's because of this 2 in front of the x to the 8 up here, and this -1 in front of the x to the 8 on the bottom. Okay, and I think I'll just do this one. I'll just talk it through, but I won't graph it. This is going to take too long, and this video is already long. So what do we have here? We've got x to the 3rd on top, x to the 7th on the bottom. That's proper, 3 over 7, right? It's bigger degree on the bottom. That means there will be an asymptote at 0. So as x approaches negative infinity, it's going to go to 0. But then it asks, is it from below or from above? Okay. So let's think about this. Now, if I put in, what are we doing? We're approaching as we go to negative infinity. Okay, so we're putting in negative numbers, right? So if I put a negative number in here, it's going to be negative. The whole thing's going to be negative. A big negative number, right? So the whole top's going to be negative. And if I put in a big negative number down here, it's going to be negative, but then that negative makes it positive. So you're going to end up with a negative over a positive, which is a negative. So it's going to approach it as a negative, so from below. So from below, right? Because the signs here are different. But you also got to look at, this is an odd, right? This is an odd exponent. So when you plug a negative into an odd exponent, it stays negative, right? A negative number raised to the 3rd power is still negative. times 3, still negative, right? So the top's negative. Here, a negative number raised to the 7th power is still negative. But then when you multiply it by -9, then it's positive. And you could ignore that x squared because we're talking about for big values of x, and that's not going to even matter anymore. So that means when you put in a really big value here, you're going to get a negative, no matter how big. So that means the graph is doing sort of like what this one's doing. It will approach the x-axis from underneath, Okay, so cross your fingers if I'm wrong. This video is going to be longer. Okay, we got it right, and that's it. Thanks for bearing with me, and have a great day.